Okay, let's start. Hello everyone, very good afternoon. I hope you all had your lunch, so nobody will be sleepy. My name is Rohit, and here's my colleague Raman.
Hi everyone.
We are part of the Enterprise Database Warehouse team at Expedia, and today we will be presenting our in-house tool that we built to understand and improve the performance of cluster by analyzing the small file problem. Let's start. Let me give you an overline of the whole presentation. First, we'll try to explain you the problem of small files. Then we'll show you the architecture and the flow of the tool that we have built. And then we'll proceed to the results, the powerful results that give us insights that help us to do all the things. Let's do it. So let me give an overview of Expedia's Hdfs cluster. So 4 years ago, we started with 15 nodes. And the way we are growing, we are currently, at the start of this year, we had 317 nodes. And by the way we are growing, we will be having around 600 nodes by the end of this year. Our cluster has 3,000 users. Out of that, 1,500 are unique users using it all the time. And it caters to 50,000 jobs per day. Out of that, 60% ETL and 40% ad hoc jobs. With all this massive usage, we are also, the number of applications that are running on our cluster are mostly Hive, MR, R, Pig, Scoop, and all are running this on this cluster all the time. So, trying to understand the usage of this tool, there are like many businesses which are using this tool. It's a multi-purpose, used by all the businesses. So we are generating massive data of all kind of data. And it's being used for data science, monitoring, analytics, ETL, you name it, we have it. So where's the problem? So the cluster is used by all the people, and everybody is using it in their own way. They are creating lots of small files. And it's a general understanding that small files are not good for your cluster. Why? Once you have a lot of small files, so there's a limitation in the name node that it cannot have all the information of the files. It's stored in the name node. So scaling Hadoop to billions of objects is limited by the hardware capacity as well as the JVM computation. You cannot scale it a lot, right? You have to keep all the metadata of all the files in your name node, and it's limited. Second problem, that with lots of small files, you cannot have very smooth maintenance of your name node because the restart time of that will increase exponentially. The more you have small files, the longer it will take to restart. That was one of the problems that we faced. Now look into the more problems. So inefficient data access pattern. So let's say you have lots of small files, and you're running your jobs, right? So Hadoop is not designed for small files. So it's designed for accessing large files under streaming, right? So what happens is, with lots of small files, you have to go lots of seeks and hopping between data nodes. And this is a very, very inefficient data access pattern. Another problem that makes jobs slow. Why? Because every map task has to access small files, right? And there's a small overhead of bookkeeping involved in that. So with lots of small files, there will be lots of map tasks. Lots of map tasks means there is a lot of bookkeeping to be done. For the same amount of work which was happening with the large files, totally changes when there are lots of small files. That impacts your job performance drastically. So what's the solution? Can we delete other files? I think no, you cannot delete other small files. You need them, right? That's why you created them. So what's the solution? Compaction, archival, or targeted deletion, that's not the solution. But you need a policy around that. You cannot just delete the files, you just go and randomly delete them. You need to know where exactly the small files are, whether you can delete them or not, what to do with them. You need to know who's creating them, when they're creating, how they're going. You need the answers to all these kind of things. But you don't know where they are, right? That's where our tool came. So we had this idea that we need to understand how our cluster is being utilized, who are using our cluster, how they're using it, their pattern, their over the time pattern things. So we did this thing. Now my friend Raman Goel will explain the architecture of the tool. Raman.
Thanks, Rohit. Is everyone still awake? Yeah. So as Rohit talked about that, this is a problem about the small files that we don't know like where exactly they are located and who is creating them. So we created a tool. With that, we can get a holistic view of the small files, find who is creating them, track their growth over time, and also bucket the files like as very small, and what should we do with them? Like, should we compact them? Should we do the deletion? Should we repartition them? And whatsoever. Okay, so I'll tell you a little bit about the architecture we follow to build this tool, and then I'll deep dive in more in one of the levels. So what we did is like we fetched the raw FS image from the name node. Everyone is aware about the name node, right? So we fetched the raw FS image from the name node, and then we converted using OYV interpreter to LSR format. After that, we got some information about the files and directory level information. We then aggregated them, and finally, we moved the data from our Hdfs to MySQL for creating different dashboards around the data we collected. So let's go more into the first part, which is FS image processing. So we fetched the FS image from the Hdfs cluster, and then using the OYV interpreter, we got the LSR format. So why we need to do that? Because FS image has the name node information, but it doesn't contain directly the file level or directory level information. So we needed to convert it to LSR format. And also we customized the OYV interpreter because like our FS image was around 20 GB in size, and with the OYV interpreter that's in the market, it was taking around 100 GB of memory. So what we did some customizations in that, and we reduced the memory to like 1/5 of the time, and it's now taking only around 20 GB of the memory for a 20 GB FS image file. So let's go into the attribution and aggregation part of it. So these are the attributes that you get directly from the FS image after you convert it to LSR format. So owner name, group name, size of the file, these are available directly. But you needed some information on the directory file level information, so we need to aggregate those things, like number of small file objects a directory has, number of namespace objects a directory has, and the smallest, largest file size, and difference in size, like how the size is increasing since the last run. So we wrote some custom UDFs and pig scripts to aggregate the information from the attributes that we have. So we calculated the roll-up size. We created the parent-child relationship, as in the path hierarchy for each directory. We also calculated the min, max, and average file size each directory have. And finally, using Scoop, we dumped the data to MySQL for creating dashboards. So this is the final part. So we are using an in-house tool called Cyclotron to create our own dashboards, and everyone can go and leverage our data to create their dashboards. That's what like everyone is doing at Expedia right now. So once we dump the data, everyone can use that and create their own dashboards to know like what kind of files they are creating, are they creating any small files, and how they should look at that. So let me just summarize what we did on the architecture level. So we downloaded and interpreted the FS image file. Then we attributed the information out of that, and then we aggregated the information, and finally using Cyclotron, we created some dashboards, and that's what is being used at Expedia right now. So now Rohit will talk more about the dashboards we created and how they look. Thanks.
So all this processing and the churning of data, but it gives us a powerful information that can be utilized to get lots of like insights into the cluster. Let's go into them. So what we did with the data is that they are like categories of files, right? They are size categories, like files that are very small, size that are like average, or files that are really large. So we categorized them into 3 bucketing models. One was less than 10 MB, other was around 10 MB to 70 MB, then 70 MB to 100 MB. So we are making decisions based on their sizes. We can categorize them, we know who is creating them, we know where they are. Based on that, we can make smarter decisions about them. We also got some really interesting key points. Like for example, we had 10 million 0-byte files. So without this kind of analysis, you cannot really know where the 0-byte files are. 10 million, that are huge. And we also have that is to be investigated for deletion, repartition, and compaction. So now you have the data that you need to make decision on. And that's the powerful inside of the whole this thing. You know where they are, and you can take decision on them. We also know who are the owner of these small files. So you can track them, you can track those teams, you can ask them to change their code or make some changes in their archival policy or use logs maintenance, something that can reduce the number of small files and improve your cluster performance. So this is a dashboard. You can see a clear segregation of the files that can be repartitioned, the number of files, small files that can be deletion. They are candidates. They're not for deletion, they're candidates that can be investigated for deletion. And third one is the files that can be compacted. So now you can see 89.9% of the files are less than 10 MB. That's huge. We are talking about 11.5 petabytes of data in our cluster. Out of that, 89.9% files are very small files. So now you can see the system was how it was abused, and we found out that. So you can also the second column, second row is the distribution of owners for files that should be taken action on. So you can see their clear sorted order. You can identify the biggest culprits and the smallest ones. You can go after them in a priority order, and you can keep on improving things. Let's go into more dashboards. Okay. So this distribution shows the distribution of owners of small files that can be deleted. So now you can see the first owner has 24 million small files. He's the biggest culprit. You can go after him, and that will solve your half of the problem. Let's go to the next one. So this is more detailed information about sample directories that can be purged. So you can see a directory information, the average file size, largest file size, owner name. Let me zoom into that. Okay, now you can see the average file size, owner group, number of small files in that folder. So now you can go on and creating dashboards. So all this data is stored into MySQL. So you can also write your customized queries to get some particular kind of data. So for example, you want to monitor a particular directory. Let's say you have users who want to know that how their particular directory is growing. You can create your own dashboards by simply writing a custom query for that. So this dashboard is totally customizable. You can write your own query, add your own alerts on that, get alerts when you're exceeding the size of your directories. That's a powerful tool to get instant notification. This is one of the best charts. It shows the top 10 users, small files versus non-small files. So you can see a directory information. A particular directory has very high portion of small files compared to all files. That means this directory is the first candidate to be considered for investigation. This is where the whole bottleneck is. The biggest culprits that are slowing down your cluster or impacting your cluster's name node. You can go on one by one after them. They are in sorted order. Go to the next one. This is the last one and the most important one. This shows the power of this tool. So we had this app logs directory that we came to know that it has 10 million small files, all log files. Before this, we didn't know, and it was impacting our cluster in a bad way. So if you see there's a sharp dip, that's where we found out and we cleaned it up. It gives you a clear information that over the time how it was growing. So it's a time-based chart, but you can see over the time the directory was growing in size. And when we started using our tool, we noticed that yes, this is the particular directory which is growing in large size, and we must do something. We cleaned it up. There was instantly a dip, and there was a huge performance impact. Apart from that, there are more other success stories as well. Flume was creating lots of log files. We found out that, and we went to the engineering teams and system engineering teams to figure out the solution for that. They changed the archival policies and log retrieval, and now we have a pretty good policy about that as well. So these are some of the success stories that we have in Expedia that are helping us a lot. So future work. So it doesn't have a real-time analysis. Right now we are processing this information every day because the system takes a lot of time to process the raw FS file. It's a very big file and takes around 3 to 4 hours to finish. So right now we are planning to make it as real-time as possible. Apart from that, we are also building a customized compression utility as well because there is no one thing to solve our solution available in the market. So we'll be building now on top of this a compression utility where users can just click and their directories will compare it based on their rules. Okay, conclusions and questions. Thank you. Yeah.
So when you say compaction of smaller files,
Yeah.
like that process is common in a lot of things in Hadoop, and even so that's a big part of thinking.
Yeah.
When you compact files, do you have another file format that you're putting it in to reverse that?
Yes.
Or are they just being concatenated?
So compression utility is a future work which we are planning right now. So we have plans to use sequence files or different file formats. We'll be using that.
So we have plans to open source it, we built it out just recently, so we are in the phase to open source it, yeah.
Yeah, it's an industry-wide problem, right?
How do you determine the files to be purged or repartitioned? Is it a review of the analyst
So we have categorized them into their sizes, plus we know the owners of who are creating them. Based on that, we go and investigate that for these particular category of files, what is the right decision for them. Yes. It tells you the location and owners and sizes. Bas-
That one we can directly see the Hdfs directory structure, right?
you So you won't get a holistic view of the entire directory and the number of small files particularly in them. You'll get the file information, but not small file information particularly. So like for example, you want to see the growth of small files over the period of time. That's a major like insight that okay, so particular directory is growing beyond limits, right? Too much, too very fast. That's the time you want to like stop it because small files you cannot avoid them. They are going to be there. This is the way businesses are using it. So you want to find the best candidates for investigation. So this tool enables you to that kind of information to which one to target first, because we have like 11.5 petabytes of data and like 3,000 users. So we cannot go after them each of them, right?
And also like some of the information is not aggregated there, so you need to do that.
Yeah. So the OIV interpreter that's already available, it was not able to scale for us because our FS image file size was around 20 GB. It was consuming 5 times of the memory, so around 100 GB of RAM. And for us, it was not working. So we changed so it has some mappings between node ID and the parent ID mapping. So we had these mappers, we changed those maps sizes, which allow us to optimize the size of memory footprint of this whole tool. So we are planning to open source this tool, and we are in the process of that. You will hear soon.
How do you convert this image to the LSR form?
Yeah.
Using OIV interpreter, we did that.
You can get it in CSV and LSR is a separate command.
Yeah. So first of all, we improvised over that as well. Okay. So it was the original one was not working for us. It was not able to handle the size of FSB file that we had. It was taking a lot of time as well. So
You mean like the format of the file we got after that? It's TXT.
Yeah. It's a simple
Yes,
CSV
it was
file,
TXT. Yeah.
And as you mentioned that it was taking 100 GB of RAM, right?
Yeah.
Right, then you reduced to 50 GB. How did you do that?
So we changed in the code you will see some node ID to parent ID mapping. It uses some maps. Okay, if you change some of the code and some mapping sizes, it can be improvised. That's the code detail. You have to share the code to understand that.
How frequently you run this job to store in MySQL?
So earlier we were running it weekly, but now we are running it daily.
So the time series graph you have shown, so it was weekly.
Yeah, it's a daily graph which you can filter more drill down as well, so like monthly, over the month, over the week kind of things. So you can build more charts because all the data is in MySQL. So you can write your own query to create dashboards. That's also an interesting thing.
No, just I'm asking about the job that you are getting
Okay.
the metadata and storing it into MySQL. So how frequently you run this job?
So it takes around 5 to 6 hours to finish this job on our cluster. So we run it like every day.
Yeah.
So for Expedia, the block size is 128 MB. Yeah.
Size of the files, is they usually large?
There are all sizes of files in our cluster. It varies from like 0 bytes to like GBs.
Yeah, I understand, but you're creating these reports for them to get rid of the small files.
Yes, exactly.
So that still, from your experience, does it mean that they mostly use large files?
They use small files, in fact. Like I showed, like 89.9% files are small files, so most of them are mostly using small files only, but they don't know.
Yeah. 89% are less than 10 MB in our cluster.
Sorry, 89% is less than 10 megabytes?
Yes,
That means they mostly are small files.
Yeah.
exactly. Mostly are log files or some other small files, so they can be cleaned up as well, but we never knew that they can be cleaned up and where they were. So this tool enabled us to find out them and then start cleaning them. Better improve our policies for deletion or archival.
Sorry, archiving where?
Archiving into, I think, some place. Yeah, anyway.
Outside of Hdfs?
Yeah,
Yeah.
some different place. Yeah.
Oh, that sounds weird. After getting small files.
Mhm.
So after that, what you use to solve the problem of small files?
So that's where we are building the compression utility now. Then now we know that we can use the compression utility as well as our system engine hitting. They go on and even delete those files that they are sure there can be deletion as well. Yeah.
You will notify this to business user that you are creating the small files and you articulate it.
Yeah, it's more about educating your users to use the cluster in a better way.
Because this is an impact on the cluster.
The main thing is for the
users to know that the files that they
And now we know.
Exactly.
and this is a useful tool to help them see when
We want to educate and make aware our users that they should use the cluster in the right way because they cannot just go and play with the cluster, right?
So see, we cannot delete like file if we see this small
Yes, we
file.
don't
You
know
need
that.
to educate them so that they do them themselves, not
So
us.
do they do a lot of combining files as well to make them into a larger block as they process more quickly?
Exactly, yeah. Yeah.
Not right now.
Not right now, that's what we want.
So the whole problem was that there was a whole bunch of stuff going on and we didn't have a lot of insight because there weren't tools that existed. These guys built a bunch of tools and then our business partners are now aware of what they're doing. And so now we can then start to A, clean up the environment, but then B, also develop tools that will help them as they build new applications.
And they get fewer calls saying the cluster is slow and we
Or
don't
we
have
get,
enough mappers.
correct, or we get fewer calls from them going, your cluster's slow, right?
Because the problem was before that
I
people were
know
saying,
it's a problem.
Yeah.
people were saying, well,
Yeah,
there's loads of small, you're creating loads of small files, you sign everything down. You're like, well, where are they? What are they? Yeah, I've got no idea. You know, so now they can turn around to us and say, actually, these are the files, and these are the ones that are like 0 bytes, and the ones you should be first.
And they don't realize, the users may not realize that they're just doing a star star.
Yeah, we got guys writing, they're writing, all kinds of, they've got notebooks running on
And you wonder why
Jupyter.
they dropped around.
Yeah, exactly.
Yeah, and so that was what we're trying to do.
We've got to shine a light on it first, and then you can do something about it.
Especially streaming applications where they
Yeah.
go over the limit of block size instead of time-based limit. We're trying to teach them what is your real need, right? And we just based on block size. You wait for the file to fill up to 128 megs and then move on. So just
Yeah, so basically you need policies around these things, but to create policies you need to understand what's happening currently so that you can create better policies for customers.
It's back to governance, as we heard in the keynote speech, right? We heard a lot about governance in the keynote speech. Pardon?
Helping your users be better users.
Yeah,
Yeah.
Yeah.
I was the worst.
Because that's the long-term solution, right? Cannot just keep on doing it yourself. They must be using the cluster in a better way.
But the old problem is between the keyboard and the problem is between keyboard. Thank you.
Yeah.
Will your custom OIV tool will be open source or contributing to others?
So currently like OIV is deprecated, so I'm not sure. Like the TXT conversion, you can only convert to XML right now. So what we did was for the TXT converter. So we will continue to use it for our tool for the open source. I'm not sure if we can do that.
Sorry?
So the TXT conversion of OIV interpreter is deprecated right now. So it's not shipped with the newer version of Hadoop. So the only format that's available is XML format. So we'll continue to use it for our tool, like
So
in-house.
we'll explore the opportunities of open source.
We
as
will
well.
explore that,
Yeah.
but I'm not sure currently.
Yeah, right now it's just in-house tool right now.
Then you are using older FS image, converting to older FS image and using all the deprecated LS option.
Sorry.
OIV LS option is now deprecated option. Is it?
Yeah.
the LSR option, the UID, is like a deprecated option?
Yeah,
Yeah,
it's deprecated.
but we're looking to extend this.
Exactly.
More of
Yep.
the versions that work with
Yeah.
There's a new version of UID.
They have like upgraded it, but this conversion to text file, that's not been upgraded yet.
They are doing
So
only to
we are in
XML.
conversation with them as well.
Yeah.
Maybe we will figure out a strategy to include that as well. So you can send an email to that email ID. We can notify you.
It's one of the things that we're trying to work on.
Yeah.
How we get things sourced and how we then notify the.
Yes.
One of our very first explorations.
Did you guys have a number for what was the ratio for total number of blocks in the cluster to the number of files? Total number of files of cluster.
Nothing like that sort.
We don't have a number for that yet.
No, basically you get the total number of files in Nambari and total number of
Okay.
blocks available, right? So I was wondering if you have those numbers.
We can create this from, so we are not storing any block level information here. Only the small, only the file level information is stored. File and directory level information is stored in the tool itself. So for the block level, I think we can use Ampari that mentioned, right? We have HBase, I guess, yes.
You ever run into heap memory issues with the name node?
Exactly.
Exactly.
Yeah.
The small files keeps us busy, so. Any other question, guys? Okay, thank you.
Thank you.